Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Agus Kumaiti. I came from Automation Engineering Study Program Politeknik Perkapalan Negeri Surabaya. In here I would like to explain about my latest research with the title of Automatic Hull Fracture Detection System using Template Matching. Kill fin is a point on the keel of the ship that serves to increase the transverse friction of the ship. It can increase the stability of the ship. The fin is very susceptible to friction and corrosion, which results in a greater possibility of cracking. So then we offer a hull fracture detection system using template matching feature. Template matching was chosen because of the ease of computing offered and the simpler concept. The more data set templates are used for training will increase the accuracy for detecting the fracture. Actually, the hull cascade is a kind of Violet-Jones method which combines of four main cases. First is hull-like feature, second is integral image, the third is ADAPU's learning algorithm, and the fourth is a cascade classifier. The computation of this system is very fast because it only depends on the number of pixels in a square, not every pixel value of an image. We can calculate the hull-like feature by finding the difference from the number of pixels of the area inside a square or rectangle. An example of hull-like feature is presented in figure 2 below. Hull-like feature value, or F-HAR, was obtained from the sum of the difference of the area, or F-black, against the sum of the difference of bright area. An integral image is a technique for quickly calculating feature values by changing the value of each pixel into a new image representation. The ADAPU's learning algorithm is used to improve classification performance with simple learning to combine many weak classifiers into one strong classifier. A weak classifier is a correct answer with an inaccurate level of truth, while cascade classifier is a method for combining complex classifier in a multi-level structure that can increase the speed of object detection by focusing on only possible image areas. In this study, there are 7 stages to create the hull cascade dataset. For the beginning, we are creating a positive image. This step can be done by making some positive images of the PMP format and put them in positive or raw data. More images, more precision the system in order to detect the object. The second step is creating a negative image. By default, there will be 200 or more negative image background in the negative folder. The third step is negative into file. After adding the negative samples, the process continues to create the negative info. The fourth step is creating positive info file. We are cropping the area as object for all positive images. The fifth step is creating the sample. This step will make a positive vector file in vector folder. The sixth is hard training. And the last is converting the hard training result to XML. In this case, we use 200 data sets for positive image and 200 data sets for negative image. As the result of testing performance, this research has successfully proven that through digital image processing technology, the visual inspection process will become easier with the help of a digital camera. For wider application and to apply this method to a mini PC or portable devices, it is necessary to add template datasets with various types of crack images to maximize the performance. We are making several testing schemes by changing the thresholding values. Figure 5 shows at a thresholding value equals to 1, the system is unable to detect cracks in the hull or build skill of the ship. At 0.99, the system shows an improvement with the percentage of success equals to 90%. A constant result is shown in the thresholding 0.9 to 0.98, with the percentage of success reaching 95%, and success reaching 100% was reached when the thresholding value is equal to 0.89. As the conclusion of this research, the template matching method using hard cascade has been successfully applied to detect cracks on the hull and shots of the ship. The accuracy rate of success in the study varied by 95% for the range of limitation values at 0.9 to 0.98 and 100% at the limit value of 0.89. Further studies need to be carried out on the verification study of hull fractures and the development of this research, such as the testing of shipwreck detection systems in underwater imagery, so as to facilitate the underwater visual inspection process before the docking process is carried out. This is the end of my presentation, and thank you.